All right, so we're going to start Module 3 today. Module 3 is all about forces. So far, we've talked about motion and we've talked a little bit about acceleration and things like that and momentum. So we've had things that deal with forces, but we haven't actually talked about what forces are. Okay, so a force is any object, any action that can change the state of an motion of an object. So simply put, a force is a push or a pull. Okay, when you're changing the state of motion, a force is acting on it. Okay, they're part of everyday life. There's forces acting on us all the time, and the one big one obviously is gravity. Gravity is a force that's acting on us all the time, pushing things downward. Okay, now it's not the only one. The electromagnetic force and micro welds is something that you probably are going to see in your smart book. Those basically keep us on chairs and keep computers from sliding off of the desk and keep things where they are. So forces act on us every day, even though you might not think about it all the time, right? There are four fundamental forces in the universe. This slide, I'm going to be honest, we're going to talk about them, and that's pretty much it. So gravity, electromagnetic force, which is basically just friction, strong and weak nuclear forces are the four fundamental forces. So strong and weak nuclear forces, we will literally never mention again. And we haven't done anything with atoms yet, but basically it's what holds protons and neutrons and all that stuff together. It's what holds atoms together. Electromagnetic force, I kind of mentioned, is basically just friction. And what causes friction are tiny little micro welds, is what you call them. If you think about just think about the cover of this book, right? You can see it's shiny, right? It's pretty smooth. I mean, you can't feel it, but it's pretty smooth. But if you would look under that with a really, really powerful microscope, you would see that it is pretty bumpy, right? And that's why when it goes onto another surface, even though that's smooth, it's really, really bumpy too. Those tiny, tiny, tiny little bumps push together, and that's what causes friction. That's the electromagnetic force. And then gravity obviously is the force. There's a lot more to it than this, but gravity is basically just the force that pushes us down. Okay, they vary in strength. Nuclear forces act over very, very short distances, but they're really, really strong at those short distances. Gravity, on the other hand, acts over really, really, really large distances. So if you think about like the sun, affecting all of the planets in the solar system. The sun is so massive that it creates so much gravity that it holds together the entire solar system, right? On a smaller scale, the Earth holds everything on it because it's a lot more massive. So things that are much more massive have more gravity, okay? But if they're farther apart, the force of gravity goes down, right? So they can act at a distance or through contact, right? Pushes and pulls are contact forces, pushing a lawnmower, catching a ball, even pushing down on the desk or typing, any of those are contact forces. But things like gravity, things like magnets, those are called field forces. So anything that acts over a distance is called a field force. Those act over a distance. Okay? Now, this is one of the most important kind of slides in the whole module, honestly, the whole chapter. This definition, the net force, is the combination of all forces acting on an object. Now, we're not going to really get into it, but when you're drawing force diagrams like this over here, you should put gravity in the normal force. The normal force is basically just what's holding us up, not letting gravity smush us down, basically. But we're not really going to do that. Once you get into physics, when you're a junior or senior, you'll probably do that a little bit more. Okay, but this line right here, when there is a net force acting on an object, the object will accelerate in the direction of that net force. Okay, so we know what accelerate means, right? It's changing velocity. So basically what this means is if there's a net force acting on an object, it will change its velocity. Now, that might mean its velocity is zero, a net force acts on it, and then it moves. But this doesn't mean that just because this does also mean that just because something's moving, it doesn't necessarily mean there's a net force acting on it, okay? If you are going in a straight line down the interstate, traveling at a constant speed, or you got your speedometer set to 70, the net force is zero. That doesn't mean there aren't forces acting on you, right? Because you're moving. There had to be an initial force. So all that means is the force of friction and air resistance and stuff against you balances out your car's engine and moving forward. Okay. So just because you're moving doesn't mean that there's a net force. Now, when you speed up, what happens? Now your engine in your car is overcoming that friction force. Then when you slow down, well, now that friction force and the air resistance and the brakes, right? All of that stuff is going in the opposite direction. So the net force, the combination of all forces acting on an object, very important concept here.
Colton Dillon, please come to the office.
Okay, so friction, I've mentioned it a little bit. Friction is the force that opposes motion. Okay, there are two kinds, static and kinetic, right? Static friction, if you think of what the word static means, that's basically just not moving. So static friction is the force that resists initial movement of objects that are at rest. Kinetic friction, this word kinetic, we're going to see a lot this year, or really, any variation of. Think Xbox Connect, right? It's spelled with a K. What do you do with Xbox Connect? You move. So anytime you see that word kinetic, it's talking about movement. So kinetic friction, like sliding and rolling friction, are forces that resist the movement of two objects that are in motion. Okay? It's harder to overcome static friction than it is sliding or rolling. And then friction can also be helpful, right? Unwanted friction can be lowered. Things like your lubricants, motor oil, grease, cooking oil in pans. You don't want things to stick to the pan, so you put oil in it. You reduce that friction between the two. But then helpful friction can also be increased. Cinders on a snowy road, sticky surfaces on athletic gloves. The list goes on and on. So if you don't want something to slip, you increase the friction. If you don't want something to stick, you decrease the friction. It's really as simple as that. Okay. Now, in your book, in section 1, because we didn't talk about some of the things on in section 1, but it goes over the law of universal gravitation, and we're not really going to do anything with that. All right. So we'll talk about gravity. We'll know what it is, but basically, we're not going to use this F equals G times M1 M2 over T squared. Okay, we're not going to do that. That's a little more advanced than us. But we need to know what gravity is and how it works. We will, on the other hand, talk about weight and that being mass times gravity, and gravity is an acceleration. That'll probably be more tomorrow's lesson. Okay. So today, what I really wanted to get was this slide right here, net force being the combination of all forces, and really just knowing that if there's a net force acting on something, it's going to accelerate in that direction. The key word being accelerate, not move in that direction, right? Because again, something can be moving, but not have a net force acting on it. Okay. So tomorrow, like I said, we'll get into a little bit more with weight and gravity and weight versus mass and things like that. And then the couple sections after that, I believe, we'll start talking about Newton's laws and how that applies to all this. Okay. So a couple things to remember. You have a smart book assigned. It is not due for another couple weeks, so don't get overwhelmed by it. It is a lot, but it's the entire chapter smart book. So that's due, and that's pretty much it. Okay. So new section, we will finish out this over the next week, then take that test, and that's the quarter, guys. So, we're moving right along here. Okay. So like I said, finish your smart book and email me as always. Leave a comment if you have any questions. Thanks, guys.